Okay, so this is our official start of Big Data for the day. Welcome, everybody. Um, yeah, so first thing that I wanted to go over today was just to say, like, really good job to everybody, first of all, for in the first 2 weeks asking lots of great questions in class. But then over the past, I don't know, 3 or 4 days, especially on GitHub, asking great questions on GitHub, and even more so than just asking questions, but responding to each other's questions and collaborating that way through GitHub. I've been very pleased with that. I think that's a good sign that the rest of the semester is going to go great for us. So please continue to do that, and I will. Yeah, I think things will continue going well. I'm going to share my screen now. And so I have pulled up right now our this week's week 2 lecture notes here. And before going, kind of starting from the top and going down, I want to jump all the way down to the lab and homework for this week, talk a little bit about that, and then we'll talk more about the material. So this week, the lab and homework is another one of those sort of hello world kind of assignments, this time for something called Docker Compose, which is a tool that kind of sits on Docker and makes Docker a little bit easier to manage when you're have many, potentially thousands of these Docker containers and images that you're working with. And the theory is that Docker makes everything go smoothly, but as you've seen from the first lab, things don't always work out perfectly smoothly, and there's a lot of things that just rough edges that we'll have to smooth out. So there's another one of these sort of tutorials you click on, and it'll take you to the step-by-step instructions of what you have to do. And today in class, and on Wednesday as well, we're going to run through like most of the parts of this tutorial, highlighting some of the key things to take away. But I still want you to go through the steps so that you sort of smooth out whatever rough edges you encounter on your own. So last week it was just the lab, so the small 2-point assignment. This week it's a little bit more involved. Personally took me about 2 hours to run through this entire tutorial. So if everything goes smoothly for you, you can expect it takes at least that much time. I would budget probably at least double that though, for assuming there's no major catastrophes with programs not installing or things like that. Oh yeah, so last week it was just the lab. This week it is both your homework and lab for this week. So it'll be worth 10 points. But also remember that you have that Twitter coronavirus assignment too to work on, and this would be another good week to make some progress on that. And you do have a lot of time to work on that one, but remember that it could potentially take a long time to do the computation for that one, so you want to get the code done for the Twitter assignment kind of as early as possible. Any questions about anything sort of administrative before we kind of start on the material for today?
I kind of have a question on the Twitter homework.
Sure, go
just
ahead.
Result, what we want. At the end of the README, it says that our results, we want to know how many times a certain hashtag was used, which the code doesn't currently do. It just separates them out by language or by country. So should we change the code to give a total at the top for each hashtag?
Oh, good question. Yeah, you don't need to have a total overall total, just total per language and total per country.
Okay, so then we should have separate. Should we have separate files for language and country when doing this final command here with the visualize?
Yeah, that's right.
Okay, great. Thank you.
Good question. Yeah, so also, so with this homework, the Twitter homework and the homework for this week, there's no like sort of strict test cases, no continuous integration like there was for the very first assignment. And yeah, so if you're free with this Twitter homework to kind of format things however you want, whatever makes sense to you, whatever's kind of easy for you to understand. And also you should be thinking about like, so this is going to be in a public Git repository that future employers can potentially look at and possibly in an interview talk about. So thinking about formatting things in a way that is good for that kind of audience as well. Starting next week is when we're going to have a homework that sort of combines all of these things together, where you'll be using Docker Compose combined with the continuous integration on GitHub. And that's when I'll have a much more like rigid set of requirements of, I'll provide you some starter code and you'll have to fix these exact 10 issues to fix these exact 10 test cases so that the continuous integration passes. But these two assignments, much more flexibility. Good question. Any other questions about anything so far? Okay, so today, continuing a little bit with Docker, talking about this Docker Compose program, and really the main thing that we're going to kind of get into is what I kind of call the Instagram tech stack. So we'll talk about all of the technologies that go into how Instagram is running their back end, and Instagram I think is big enough that they qualify in the big data regime, and we'll see that it's actually relatively simple sort of set of technologies that you're using, that they are using, and we'll be able to throughout the rest of this course build on those technologies to create our own web programs, this search engine. So the first thing that I wanted to mention was there's this idea of a 12-factor web app. And this is not something that we're going to spend too much time talking about in this course in detail, but it is something that's like historically been really influential in this big data world and generating large-scale web apps. You'll see people often talking about if they're doing something, does it agree or disagree with the 12-factor web app? And so I'd recommend just taking a look at this, but it's kind of really written at a fairly high level. So it's more geared for, say, a senior engineer or a non-technical manager trying to understand what the technical people are working on at a high level. So we won't talk in detail much about this. The only last thing I'll say about that is that all of the sort of things that we're doing in this class throughout the rest of this course will be fitting into that 12-factor framework. There's no situation where we're going to break something, one of the 12-factor rules. And so maybe, yeah, a quick skim like at this point, and then a quick skim at the end of the semester would be sort of the right way to approach this website. In terms of tech stacks, so yeah, we're building up to talking about Instagram tech stack and what technologies are they using under the hood. Before we talk about Instagram in particular, though, I want to mention this, what's called the LAMP tech stack. So it stands for Linux, Apache, MySQL, and PHP. And this was really popular for web pages in the 90s and 2000s. It's what Facebook was originally running on. And they're still running on essentially the same stack, only MySQL, the database engine, has been replaced. It's no longer what's powering Facebook. And now they have their own sort of custom technologies for the database. On this class, instead of using MySQL, Postgres is going to be the main database that we'll use. So you'll see Postgres written out both this way and this way. Even though it's not quite the same thing, it's still the same technology. You'll also hear people pronouncing it PostgreSQL or PostgreSQL. Those are all sort of interchangeable pronunciations. So back in the day, say 90s and 2000s, it was MySQL sort of the standard, most popular database for all of these web applications. And the reason for that is it used a lot less overhead than Postgres. And the main reason it used less overhead was because it used threads instead of processes for handling any parallelism that had to happen in the database. So again, we sort of talked about this a little bit last week, but processes was with that forking function, and it's something that's sort of the only way in Python that it's possible to do multiprocessing. MySQL uses the much lighter weight threads though, and that's why, especially on older hardware, it was able to be faster. But again, because that historically had a lot more bugs than PostgreSQL, they've also not really had a focus on data integrity issues, kind of really embracing the move fast and break thing philosophy, whereas Postgres philosophy has been, if you put something in the database, it absolutely has to be there when you ask for it. For most sort of like webby websites like Facebook, who really cares if we forget that a like happened? So that's why MySQL used to be good enough. But nowadays, because hardware is so cheap compared to what it was 20 years ago, sort of the overhead of Postgres is not really an issue anymore. And these days people are this is kind of the standard database that people are using for web development. Sort of the vast majority of this course, starting with next week, is going to be on like this database system, Postgres in particular, and how to, the details of using it efficiently with large-scale data sets. We're just talking about this kind of overall architecture, how it fits into this big picture, because I think it'd be a shame to talk just about the database and not spend a week talking about how you actually build something like Instagram with this database as the back end. So that was the LAMP stack. It's kind of, back in the day, it was the most popular. Even today, nobody would think it's weird if you were using the LAMP stack to develop a website. But based on this name LAMP stack, people started calling Windows-based products the WIMP stack. And so WIMP standing for Windows, IIS is the name of the Windows web server, and then still with MySQL and PHP. It's the WIMP stack because it's just not as good as the LAMP stack or the Instagram stack that we'll talk about. And even Microsoft agrees with us on that say Microsoft Azure, so that's their like cloud hosting platform, their equivalent of AWS. Most web servers run Linux, most servers run Linux. So even Microsoft is sort of dominated by Linux. Sort of the only non-Microsoft web page that I know of that runs Windows products is Stack Overflow. They're all based on this WIMP stack right here. But then even Bing, if you click these links, or Outlook.com, both Microsoft products, they both have dependencies on Linux. They would not be able to run without Linux. So it's even Microsoft is not fully able to work with just Windows. And then, so back in the day, people were really making fun of this stack because there's 3 worms that spread around the internet in 2001. And even though they only infected Windows computers, they caused so much damage to those Windows computers, causing them to create all sorts of web traffic that the internet, for 3 weeks for each one of these, effectively shut down, that nobody was able to access any website because of bugs in the Microsoft web servers. So the takeaway story is that nobody uses the WIMP stack these days, not even Microsoft. And if you were going to develop a product based on Windows, people would just make fun of you. Like, why are you doing that? That's not what people do. Any questions as high level of the alternatives to the Instagram stack? Any questions about that before talking about what we'll actually use in this course? Okay, so here's some details based on this blog post from 2011 from Instagram. Yeah, so Instagram maintains a instagram-engineering.com website where they talk about all the technologies they use, and their setup's the same essentially as it is today as it was in 2011. Just the numbers are bigger, and then there's a few additional services as well. But here, this image sort of describes roughly what's going on, and hopefully this is, my handwriting is legible. So Instagram, all the computers that are running it are divided roughly into sort of two categories: what's handling the web service and what's handling the database. And when you get a new connection to the server, so here the blue connection, it first comes into this program called a load balancer. And this load balancer decides which web server is going to handle the connection. So in order to scale up Instagram to very large scales, all they have to do is add more web servers down here, and the load balancer will ensure that whatever web server is not currently overloaded is going to get a new connection. So up above in 2011, they had 25 of these web servers. So Django right here is the name of the web server that they use. And so since then, in order to scale up, all they've had to do is add new web servers, and things just kind of go according to plan. Yeah, again, that the homework assignment for this week, the sort of outline of the web service that you're creating is all fitting this model where it's just sort of trivial to add more web servers, and that just instantly makes the product scale better. Once the connection goes to a web server, the web server has to talk to the database. So for Instagram, getting like your password and all your who you're following, all your account details. And the database is significantly more complicated than the web server. It again goes through a load balancer to, if you have multiple database servers, Instagram at the time had 4 database servers, deciding which one is the appropriate one to handle the response. And you notice that I've added this sort of dashed line between these different database servers because it turns out that web servers never have to communicate with each other. So would say it's very easy to horizontally scale a web server. Horizontal scaling just means adding new computers into that are exactly the same as the previous computers that you had in order to scale your service. Database is a little bit more complicated to do that horizontal scaling because occasionally they have to talk to each other. And that's one of the things that we'll be sort of talking about throughout the rest of this course is how do databases manage to do that. The sort of technologies that we're using for each of these steps are written over here. So Nginx, the name of our load balancer, that's the same one that Instagram uses. Instagram uses Django for their web servers. We'll use something called Flask plus Gunicorn. I'll say more about that in a second. And then PG Bouncer for the database load balancer, and Postgres for the database server. That's exactly the same tech stack that, that Instagram is using in the database. So if you're ever building a web page and you want to scale largely, if you think that Instagram is a large enough scale for whatever your company might be, then all of the techniques that we'll talk about in this class, you can just do that in your web page that you're building, and you're guaranteed to be able to scale up to Instagram size because Instagram's already sort of accomplishing that. Yeah, so this is the sort of map of how all of these services fit together. Again, today we're going to talk really high level about this Nginx, Flask, Gunicorn, and maybe a little bit of PG Bouncer, and then the rest of this class starting next week is going to be focusing on this Postgres server and how to work with that. So a little bit more details about what each of these are doing. Nginx, so load balancer, it's again deciding which web server should handle whatever the next request is. manages all the sort of low-level technical networking details so that your applications don't have to. And the most important of those is the HTTPS. So if you have encryption on your web page, your web server doesn't have to deal with any of the logic for encryption. It's all handled at that Nginx step. Yeah, this is a complicated piece of software, but that's all we have to know about it, is it just kind of sits at the front of the stack. The next thing is that that web server or the web development framework. And I mentioned before that Instagram was built using Django. So even though there's this D out front, that D is silent. You just pronounce this as Django, like it started with the J. And at the time that Instagram was being developed, this was really the only web framework for Python. It's definitely the most standard one. There are a few others that were smaller, but it's what everybody used at that time. It's what today people would call a heavyweight or highly opinionated framework, because it kind of locks you into a certain way of thinking and a certain way of doing things, which has its pluses and minuses. And Django is still widely used today. Nobody would think it's weird if you started a new project using Django. But these days, Flask is probably the most popular Python framework. And so this is what we'll be using in the class. It's a little bit easier to get started with because there's less boilerplate code than with Django. It's also usually faster, both from a development perspective and from a actual code. How long does it take to do a web request perspective? I think if Flask had existed when Instagram was starting, they almost certainly would have chosen Flask as the sort of the web framework that they were using. Again, today, vast majority of Python websites that are being developed in Flask, but it didn't exist when Instagram started, and so that's why they use Django instead of Flask. Yeah, besides these two web frameworks, there's a handful of other web frameworks. There's probably like 20 or so written in Python. And they all use this sort of standard framework, WSGI, but you don't pronounce it WSGI, you pronounce it WSGI. And this is something that as a user of the libraries, you don't really interact with, but it's something under the hood that makes them all kind of interchangeable. It doesn't really matter which one you use. And so the name where Flask comes from is because whiskey is pronounced like whiskey, and the proper way to use whiskey, proper way to drink whiskey, is from a flask. And so the Python community has sort of settled on the fact that the proper way to use this sort of web technology whiskey is with the Flask framework. And so that's why that name is Flask. Yeah, well, in this course, we won't really go into the details of using this web framework and any of the sort of complicated things you can do with it, but we will just kind of some of the basics, really simple things, so that we have a nice interface to our database to work with. We'll talk about that. Sitting on top of whatever web development framework you use, so what these frameworks do is they don't actually handle incoming network connections or any of those networking details. They just sort of what we call the application logic of what do you do once a request arrives? How do you handle that? What kind of HTML do you generate and give back to the server or give back to the user? Sitting on top of whatever WSGI framework you're using is a web server, and Gunicorn is kind of the standard one for Python, although there are, again, a handful of other ones that you could choose. This is pronounced, I pronounce it Gunicorn, other people pronounce it G-Unicorn or Gunicorn. It stands for, the G stands for green, and the unicorn is unicorn, because that is what their motto, symbol, icon is a green unicorn. So that's where the name comes from. Again, this is something that we won't have to deal with after today, and getting things set up with Docker Compose. We'll be really focused just on this Postgres database, occasionally spending a couple of minutes talking about how the Flask app up here does communication with the database, but mostly focused on the database itself. Yeah, so this, the database, extremely complicated. I think hands down, every computer scientist would agree that there is no more complicated piece of software than a database. Even an operating system, the only complexities that an operating system has, that it has to have, is because it has to support databases doing their complicated database things. In this class, we're not going to really talk about the internals of how the database does these complicated things, but instead we're just going to talk about how do you use the database to accomplish whatever tasks you're trying to do. Yeah, so since 2011, Instagram has added a few other types of databases onto their backend that do different things. We'll talk about some of the advantages of these databases kind of as it's appropriate, as we're talking about the related concept in the Postgres database in this class. But yeah, the focus will really be on, in this class, on how to use this database effectively. Another thing that, yeah, so scroll up again with this this architecture. That's what I'm calling the Instagram stack. In order to scale up your web service so that it seamlessly handles whether it's 1,000 requests a second or 1,000,000 requests a second, or even beyond that, all you have to do is get more computers so that these numbers go up to bigger numbers. And if you do that, then everything will just magically scale, and you'll be able to handle as many requests as you want. Yeah, so on Instagram itself, they actually don't use Docker, and that's again because Docker did not exist when Instagram started. Instagram, well, say that blog post was from 2011. I'm not sure when they actually founded the company, but Docker first came around in 2014, and it wasn't really until 2017, about that time frame, when Docker containers started becoming like industry standard de facto things that people are using. And so, yeah, they were what we'd call, Instagram was what we'd call hosted natively on AWS. So it's Amazon Web Services. It's Amazon's cloud service that they sell to consumers. And with AWS, it's relatively easy to add more of these computers. If we needed to add another web server, somebody has to go in there manually through their web interface and, I don't know, spend 30 minutes or so clicking buttons to get it to work right. And hopefully things are configured the same as all the other ones. And so that's a lot easier than like ordering a new computer from IBM and plugging it in and handling all those network connections and things like that, which might take a week to a month to deploy a new computer hardware that way. AWS made this, streamlined that process down into just like a half hour or an hour. But it's still like not dead simple. It's not trivial. And the real advantage of Docker is that it makes it trivial. That with Docker and Docker Compose, which we'll talk about again today, it's really just a matter of changing that number in one file from 26 to 27, and now you have 27 computers. So Docker makes all of this trivial, scaling horizontally, and it also makes it so that you're no longer tied in specifically to one cloud service like AWS. Yeah, so for Instagram, if they wanted to migrate, say, away from AWS into Microsoft Azure, maybe because the rates for computers and bandwidth and things like that are cheaper on Azure, it's technically possible, but it would take a lot of engineering effort because they would have to sort of manually bring servers up and bring them down. And there's a lot of room for just human mistake to happen with that. With Docker, though, all the major cloud providers, whether it's AWS, Microsoft Azure, or anybody else, Google Cloud, they all provide support natively for Docker containers. So you can basically just upload this configuration file for Docker Compose, and everything will magically happen. And it'll all work exactly the same, whether you're on AWS or Azure or any of these other services. Yeah, so again, seeing huge adoption right now. You're welcome to click on these links and see some graphs about like people really are using Docker in production. It's not like some theoretical academic thing. Here's a really detailed blog post from Netflix about how they converted their system over to using Docker and why they did that and all the advantages of that. But those are just nice things for if you need some motivation for using Docker. Any questions about anything so far? We'll get into the actual technical details of how to do this stuff here in a second. Okay. And one last thing before I switch over to the terminal and start walking through actually doing this stuff is this, this little meme graphic right here. So we talked about Docker. Docker Compose is what we'll talk about today. And the main idea of Docker Compose is it sort of lets us, well, with Docker, you can only, it's like one container at a time, just bringing up one sort of virtual machine. It's not technically a virtual machine, but think of it as a virtual machine, bring up one virtual machine at a time, and lots of manual commands that you have to do. Docker Compose automates all those manual commands so that it's much easier to bring up, say, 5 machines at a time or 1,000 machines at a time. Docker Swarm is something built on top of Docker Compose, which not only brings up the machines, but it sort of distributes them out to a handful of computers running on a cluster. And then Kubernetes is something that's kind of even built on top of that, where you don't even have to say, I want 26 machines. You just say, I want my response time with my web server to be down to 10 milliseconds per response, or I want my CPU load to never be above 50% on one particular machine. And it automatically allocates new machines and removes machines for you. So you don't even have to do anything manually. So you'll hear people at these like Netflix and these other big companies talking about Docker Swarm and Kubernetes in their deployments. And in this class, we're not going to talk about that. We're going to stop at Docker Compose, but it's not really too much more to do these other things. It's just kind of struggling with configuration settings and other sort of important but not interesting tasks. And so that's why we won't talk about them in detail in this class. Okay, so if there's no more questions on the high level motivation for all this, where it all sits, we're going to switch over to the terminal now. And yeah, again, you all have been doing great about interrupting me when you have questions, so continue to do that. But I'm going to start on the actual like technical details of how does this Docker Compose work and what does it do. And so you can see right now in both of my terminal windows, I'm opened up to this folder called Flask on Docker. And if I type ls, you see that there's a handful of files in here. And actually what I'm going to do is introduce this new command ls-R. And the capital R stands for recursive. And so this is a good way to get just a quick overview of all the contents of a project. So how do we read this? So dot, remember, is our current folder. So these are all the contents of our current folder. This is the same as what we would get if we just ran ls in our current folder. And then for each of the subfolders here, so here's the services folder, here's the folders inside of services. And then for each one of those folders, you can see the contents there as well. This is a very common setup for or directory structure for any sort of Docker project, that out in the root project folder, you would have a bunch of configuration files. So the configuration file for Docker Compose is called dockercompose.yaml. This .yml extension is pronounced YAML. If you say you're using a YML file, people will look at you weird. I wouldn't even recognize what that is. But if you say you're using a YAML file, then I know exactly what that is. And then inside there's this services folder, and then there's a folder inside of that for each service that you have. So at this point, we just have these two folders, an Nginx folder and a web folder. These contain our configuration files for, going back to the web page up here, for everything that's going on up here. So our Nginx load balancer, and then all the details for these web servers. And even though we might have, say, like 26 of these different web servers, just like Instagram, we would still on our hard drive or on our project folder, still only have a single actual folder for the web server, but all those servers are running the same exact code. So there's no need to create like, different folders for each instance. We call each of these different computers right here running the web server a different instance of the same service or the same web server. And so just for each service that you have, you only have one set of code, and all of the instances running that code are running the same code. We're not going to talk at all about the details of Nginx again, but there is inside of there this nginx.conf file and just configuration how Nginx should connect to the web servers, and then a Docker file for actually creating that instance. And then again, in this web folder, there's a Docker file specifically for that service. And in general, every service that you have will have its own separate Docker file. But then the web service also has a lot of other stuff, and all this other stuff is specific to the Flask framework. Are there any questions at this point? Okay. Let's see, so inside of this folder, besides all of these files, I'm going to do ls-a now. There's a handful of these hidden files. Again, a hidden file is something that starts with a dot, and these control sort of what environment variables are going to be set for your project. The reason these are hidden files is because they're files that we don't want to share with people. And if you do share them with people, potentially very, very bad things can happen. So these files will contain things like passwords to the database inside of them. And those are things that you, for example, would not want to commit to your Git repository because we don't want everybody who can look at your Git repository to know what your password is to your production database, because then they could log on and arbitrarily change all of your data. And so we'll be talking fairly extensively about how do you secure these files. And it'll actually be a very important part of your grade on the homework both this week and going forward to ensure that you have properly secured these files. Okay, that's kind of the highlight, big picture overview of what all of these files, or what this kind of structure of this project is. Before kind of digging into the details of all of these individual components though, I want to show how to use this Docker Compose command to just kind of bring the web service up and start using it, and then take it down. And in order to use Docker Compose, so I'm going back to the notes now, and we'll scroll down here. In order to use Docker Compose, you first have to download it and install it. And these commands right here will get you Docker Compose. It's just a Python program like any other Python program. The difference, though, is that you cannot directly install Docker Compose like this. If you do, you'll get compilation errors. You need to first upgrade your pip command. So pip is, again, the sort of Python package manager, how you install programs. And if you don't have the latest one, then it's not going to be able to install Docker Compose. The which command just tells you the location, which path you are finding the pip3 command in. So if I come over back to my terminal and I type which pip3 like this, you'll see that my pip3 that I'm using is one that has been locally installed in my .local/bin folder. And again, I have in my path that particular folder right here. So that's why I can find pip3 in this location. But if you were to, at the very beginning, before running the upgrade command, before doing this command to install the latest version of pip, if you were to run which pip3, you would see that you're using one that's installed globally for the system, not locally for you, and that's an out-of-date one, so it won't work. So this will get you Docker Compose. Next, we're going to, how do you actually use Docker Compose? And it's fairly simple. It's just Docker Compose, and then there are 3 commands that you can put after Docker Compose, or 3 that we'll be using in this class. Up and build and down are the 3 commands that we'll use. And I'll just put a hashtag in front of that to comment it out so that we can continue seeing that. But at the very beginning right now, all that we'll care about is this Docker Compose up command right here. And so I'll run that like this, and you'll see that we get some output here. It's taking a second to run these right here. These are the Docker images that were just getting run. So we saw in our folder over here, I'll go back to the left terminal right now in order to browse. We have this services folder. There were 2 services, Nginx and Web. And these services, let's see, they don't map directly onto these images. Where these images come from is this dockercompose.yaml file. So I'm going to open up this file, dockercompose.yaml. And here we'll see that there are 2 services, this web and this DB service. And that's where these come from, is they're defined in this dockercompose.yaml file. Talk about the syntax for this in a little bit after we're done sort of working with the Docker Compose command itself. So I'll close out of Vim over here, and now Docker PS. So that'll list all of our running Docker images. I'm going to reformat my terminals right now so that we can read this a little bit better. Maybe if I zoom out once. So I'll zoom in here again in a second so we can read it better, but I just want to show that there are 2 lines right here because there are 2 things that are currently running. And let's zoom back in. And you'll notice that, so they both have these kind of arbitrary container IDs, just like we got when we were running Docker by itself, kind of manually running the Docker up, Docker run commands. But then the names, so it's a little bit hard to see because it's a multi-line thing now, but this names column corresponds to this right here and this right here. And these names, we now have sort of nice legible names about what all of our services are called. And so these legible names are, will make it much easier for us to like manually connect to these services and run them. And here, the way these things are named is it's whatever folder that you're in. So that's sort of like your project name is the name of the folder. And then an underscore, the name of the service itself. And then sort of the ID number of that service. That here in this case, I just launched one of each of these services, but you could launch as however many you wanted. And you would get 1, 2, 3, 4, 5 up to however many you have. If I want to, say, connect to this server and run commands manually, you can use the docker exec command, just like we were using before. So it'd be docker exec, And then if I want an interactive session, so -IT for the interactive and TTY, and then the name of the service that I'm connecting to, and then whatever command I'm actually going to run. So we'll do bash here, and now I'm connected to the to that Docker image. Type ls, I can see the different things inside of this Docker image, and yeah, I can do whatever I need to that way. There's another one of those things that we'll talk about, like where are all these files coming from in a second, but the important thing to just take away from right now is that all of the Docker commands that you were using before, like docker exec or docker ps, they work exactly the same whether you created your Docker containers through Docker Compose or whether you did it manually. The Docker Compose program itself, what it's doing is it's just internally running the Docker run commands and all of those other Docker commands that have weird inscrutable syntax. It's doing it automatically for us so that you don't have to remember all the weird syntax. Okay, I'm gonna Control C right here to get out of this. And then down here, so this is again on the bottom screen, the output of Docker Compose. I'm gonna switch my screens back to split screen horizontal. And now on the, I wanna take a second to look at the output of these, of this Docker Compose up command. And you can see that there's this colorful thing to the left here saying either DB1 or Web1. And so it has sort of the name of your service at the left-hand side, whatever's to the left of the bar, or to the left of the pipe. And then to the right-hand side is whatever the output of just running Docker by itself would have been. And so these are, so you can tell like when the output came from Web1, it's labeled as Web1. When it came from the database, it's labeled as DB. Yeah, so right now I've created this this web service, and so I want to just verify that we can connect to it and see what it's doing. And so in order to do that, I have to know what ports the web service is listening on. And so we'll start looking at the docker compose.yaml file in order to do that. And so here, the web service, there's this ports section below here. And this defines the ports using that same syntax as the -p flag in Docker run. Anytime you see this sort of connection where it's like linking ports together or linking anything together, it's always on the left-hand side of the colon is the thing that's closest to you, and on the right-hand side of the colon is the thing that's farthest away from you. So what's farthest away from us is the actual like Flask container, and what port is it listening on, and that's 5000. And then what's closest to us is the Lambda server, and so the Lambda server is listening on port 3400, connecting it to port 5000. So when I run my SSH command with local port forwarding, I'm going to have to connect to port 3400 on the Lambda server. So I'm going to switch to open up a new terminal in order to do the local port forwarding, and put that down so we can all see it. And so here we go. And we'll do it on the user test. And then again, the syntax for local port forwarding, -L on your local computer, localhost, then on the remote computer. This 3400 again has to match the left-hand side of the Docker Compose YAML file. Type in my password, and now I'm connected over here. Again, this terminal is not the terminal that I launched the Docker Compose program from, but that's okay. They're just using the same ports, so it doesn't matter. And now if we come back over here and visit localhost :8080, we get this hello world, which is what the server is actually sending to us. Are there any questions about any of the steps or anything that we just did?
Yeah. So can we look at the terminal?
Sure.
So 5,000 is the port, which is what the FOSS container is listening to.
Yep.
3,400 is the port that we're going to connect to on the Lambda server.
Sorry, can you say that one more time?
So 3,400 is the port which is going to be opened up on the Lambda server for us.
Correct. Yeah.
And can we go to the other terminal that you had where you SSH? So here 8080, like, can you explain what 8080 localhost 3.4 is?
Sure. So here, the 3400 is the port on the Lambda server that we're connecting to. And then 8080 is the port on my local machine that I'm connecting to. This here is the name of my local machine. You can always just put localhost right here. So some servers have many IP addresses, many domain names hosted on the same server. And so in that case, you would have to put a different thing right here. But my recommendation is to always do 8080 : localhost : whatever number right here, which you might have to change. And then when you go over to your web browser, Firefox, it's localhost : localhost : and then the port number. And so in this case, 8080. Oops, and it's not HTTPS, it's just HTTP.
Okay.
Any other questions about any of this system so far? Okay, I'm going to flip the screen to the horizontal mode like this again for a second to talk about some of the output of this web server down here. And you'll see here there's a bunch of sort of unimportant information, but then here, every time a user connects to your web page, you'll see a new line appearing in the logs down here. It has the IP address of the connection, followed by the time right here, followed by what the request actually was. And here, this IP address is always going to be the same. This is actually on the internal network of CMC. This is the IP address for the Lambda server. And so because you're connecting through the local port forwarding, you're always connecting actually through the Lambda server. And so it's not going to be your IP address that'll appear here. It'll always be this. Over here, we have the actual request that is being sent. And this is going to be very useful for just making sure, like, actually debugging where problems in the connection. And if when you visit, so right now, let's see that there are 4 different lines here, 4 different messages have appeared. Let's come back over to our web page and refresh this. I'm just clicking the refresh button a bunch of times and come back over here. Every time I press the refresh button, a new line down here appeared. These are in the language of the HTTP protocol. These are what are called GET requests. Here is the location that I'm requesting. So / whatever the root of the web server is. And then over here is what's called the HTTP status code. So 200 means that everything worked correctly. If I were to change this up here, and instead of going to my local host, I want to, so there's another location on the computer or on the server, hello.txt gives us this right here. And come down here, we can see that the location that I typed in is displayed right there, static / hello.txt, and it existed, so it also gives us this same 200 status code. But if I were to type something that didn't happen to exist up here, we get an error message like this and a 404 error code. Here's what I typed in, the route that I was looking for, and we see that it did not actually work. This 404 tells us that that didn't exist, which is why we were getting this message over here in Firefox. So what we're going to do next is figure out how do we add a new route onto this Flask application. And this is going to, from a Python perspective, in say like the Flask world, is just going to be like 1 or 2 lines of modification to the program. But from the Docker perspective, it'll be a little bit more complicated. So I'll switch my screens back into vertical mode like this, and I'm going to quit out of Vim on the left-hand side, and we're going to find the location where this web service is actually located. So it's inside of services, so I'll go cd services, and then inside of web. And now, so here's all the files for this web project. Project folder contains all the actual source code for the Flask program itself. This contains all the Python code. Everything else is somehow like management code or settings files. And so inside of project, there is this folder __init.py. Anytime you see double underscores in Python, that means it's somehow like a special file or a special name. And it's typically pronounced in the Python world as dunder. So this would be pronounced as the dunder init file, kind of like Dunder Mifflin from The Office. And the D stands for double, under stands for underscore. So rather than saying double underscore init, I'll just be saying dunder init, and that's what I'm referring to. And I'm going to open up the dunder init file. So vim project / dunder init.py like this. And here is all of the source code for the program. The important thing that we're going to look at right now is this right here, where it says app.route /, and we have a function and then a return something here. I'm going to copy and paste this. So in Vim, in order to copy, press Shift-V to go into visual mode and move my cursor down like this. I press Y to yank it, put it in what Vim calls a register, which is like the clipboard, and then P to paste like this. In Python, it's customary to have 2 spaces between every function call to make things a little bit more readable. So I'll add those spaces. If you were running the Flake 8 linter program, it would complain if you did not have those spaces there. And then here, I'm going to add a new route definition. We'll call this example. And now here, I'll have to change the name of my function. The name of your function doesn't actually matter. It's not used at all by the Flask library or by Python. It just has to be different than any other function name. And so I'll call this example. It's very common to make whatever the name of your function is match the name of your route right here, but not required. And then down here, I'm going to change this from hello world to something else. In Vim, you can delete the contents of a string by pressing D, I, and then the type of quotation mark that it's inside of, and that deletes the contents. And so now I can type, this is a new route. Press escape, and then :W to save this, and hit enter. And now I'm going to go back over to Firefox, come up here to the top, up here, type /example like this, and we'll see that we're getting this kind of error message. If we come down here, get /example, the 404. So I've made this change, but it's not able to find it yet. Are there any questions about anything so far? Okay, I'm going to bring my web service down. So I press Control C on the program that was Docker Compose. And I'm going to rerun my Docker Compose up like this. And if everything worked, then hopefully we'll be able to see our web page now. But it looks like we can't. But we can still see our hello world. So what we'll do next is we'll talk about this Docker build command. So we did Docker up like this. Maybe actually before we go to Docker build, I want to show you if you add this -d flag. So the -d stands for daemon. It'll launch all your Docker containers as daemons. So you'll still get this output right here about things starting successfully. If I do Docker PS, here they are. They're still running, but they're in daemon mode, so they're in the background. I can still come over here and refresh my web server, and it still connects, shows the hello world up here. And now when I have something in daemon mode like this, I can do Docker compose down to stop the daemon, and it stopped the daemon. In order to sort of regenerate your Docker containers, all the Docker containers, the command is docker compose docker compose space build, and it regenerates all the files. And now we'll do docker compose up -d again. Come over here, refresh that, and come back over to example. And now that new route exists over here. This is a new route. So yeah, what was going on there? Even though I was changing this file before, I had added this new route in order to actually register that this sort of route has been added, in order to make this change sort of available to Docker so that it kind of knows that you've changed the Python file. That's what the docker compose build command is for, is to take any commands that you've modified, any files that you've modified, reinsert them into the Docker image so that when you rerun the docker compose up, it's going to be available. Are there any questions about that? I'd say the takeaway from this is that if you're making changes to any of your services, then you have to go through a 3-step process of first bringing it down, rebuilding it, and then bringing it back up. And that'll register those changes. If you're feeling like this is a little bit confusing and overwhelming, that's an appropriate place to be right now. And I think when you go through all of the steps on the homework, that will help hopefully fill in some of these gaps about like why these certain steps are needed, about like kind of what's going on under the hood. But from like, again, one of the main takeaways, or let's see, going forward from next week in the class, I'll be providing you with these Docker projects, and you'll be having to modify certain parts of these Docker projects. And so after you make whatever modifications you're making, you'll have to stop the service and bring it back up. And this is the main thing to remember when you're doing that, is that you've made a change to one of your services, so you have to bring the service down, Docker compose down. You have to recompile your container, Docker compose build, and then you have to bring it back up again, Docker compose up, possibly with the -d flag for putting it in a daemon mode.
Can I ask a question?
Yeah, go ahead.
is there anything like in, is there anything like a Makefile for Docker?
That's a great question. So as background to the question, a Makefile is what we call a build system. It's when you're using a language other than Python, where you have to compile code, so C and C++ are the standard ones. You have to run complicated commands just to convert your code into something that you can run, and a Makefile automates that process for you. The right way to think about the docker compose.yaml file is that it's like a Makefile. So if we vim the docker compose.yaml file, the syntax and things are different than Makefiles, if you've seen those before. But again, the right way to think about this is that it's providing the details of all the steps for this build procedure. This sort of combined with the Docker files as well. Yeah, it's a good question. Are there any other questions so far?
Why didn't the example URL work that second time when you saved it?
Good question. So here, so the question is that when I changed the Python code right here, why did it not work the first time, but it did work the second time? And the key answer to that is that I ran the commands docker compose down, then docker compose build, and docker compose up again. So then, yeah, let's think about like what exactly are those commands sort of doing internally. The key one is the docker compose build command. And what it's doing is it runs the, so if you recall from last week, we had a docker build command. And when you did docker build, it converted a Docker file into a Docker image. The Docker image is sort of like the instructions then of when you run docker run, it actually creates the container that is actually running. So docker build, say compiles the Docker file into an image, and then docker run runs the image. Docker compose build does this. Docker compose up does this. So let's look at the Docker file that corresponds to the web page. So it's just Docker file. I'm pressing Control-Z right now in Vim to go back to the terminal so I can see what my working directory is. I'm currently in the services/web working directory. So when I open up the Docker file, this is the Docker file for the web service. And now I'm also going to open up the docker compose.yaml file. And we'll look at the, see some of the syntax now for this docker compose YAML file. There's this build command right here. And this build command points to the folder that contains the Docker file. So services/web. So right now, I'm in the root of the project folder. Here's the Docker compose file, and then ls services/web. There's this Docker file right here. That's how we know for the web service which Docker file to use. That's the Docker file that I have opened right here. This from command is opening, saying which base image you're starting with. So last time we looked at the Ubuntu base image. This particular project uses a Python Docker image, and yeah, essentially the same. Some minor details are different, but working dir is like setting the particular location that all the commands will be run from. So this is the way to think about the working dir is like, where on this image up here are we going to install all of the files for this project? env sets environment variables. So this is the Docker Compose syntax for doing the export command. So this right here is equivalent to saying env Docker Compose equals 1. This is the Docker Compose way of doing this bash command right here. The details of what these environment variables do are not super important. They just ensure that if Python is outputting something to the log, it's actually going to get displayed and get printed, even if the program crashes milliseconds afterwards. This run command, anything that you put after run is going to get executed exactly like it was in bash. On the Python Docker image, it's using what's called the Debian Linux distribution as its base. apt-get is how you install programs that are on Debian-based distributions. And so this is just installing a program called netcat. The vast majority of Docker files will have a line that looks something like this with a big list of programs that are being installed. If you need to install something, you just kind of add it to this list right here. And yeah, we'll see details of that in a second. The key part though that I want to get to is this right down here where it has this copy command. And the copy command is what actually moves the contents of your current folder, the files that you're currently looking at that are not in the Docker image, that are in this case on the Lambda server. It moves them from the Lambda server into the Docker image. So again, the run command, upgrading pip, copy, this moves this file, /requirements.txt. So ls services/web, this requirements.txt file right here. It knows it's this requirements.txt file because we're in the services web folder, which was specified in Docker Compose right here. This is the build directory that we're working with. So it's moving this. Again, the order that things happen is close to you first, far away from you second. So the Lambda server is what's close to us. The thing that's far away from us is the container. And so this is the location in the container that this file is being moved to. Because the working directory is /user/source/app, we could just delete these lines right here that I have highlighted and just say requirements.txt, and it would put requirements.txt in our working directory, but here it's being a little bit more explicit. And then here it's copying the everything from your current folder into the user source app folder. One of the things that's in our current folder is that Python file that we modified. And so in order to actually copy the Python file that we modified into the Docker image so that it gets run when we do the Docker Compose up, we have to rebuild this, re-execute the Docker file, and rerun this command right here to recopy the whatever changes we've made into the Docker image that we're creating. Yeah, it's a lot to say. Again, Wednesday we'll go over a lot of this again in more detail, kind of fill in some of these gaps and these missing steps, and then the homework assignment will continue to fill them in for you. Yeah, I think we're out of time for class today, so I'm going to stop sharing the screen and I'll stop the recording. And we'll pick up here.